Dear students, Assalamu alaikum. I made this lecture video for my first year students according to their syllabus because some of you could not continue my online class due to internet problem. I have a plan to make more lecture videos step by step. Hope this video will help you to understand my lecture and will also help other persons who are interested on this topic. In this video, I will discuss about the preparation of some simple aromatic compounds. For the preparation or synthesis of organic or aromatic compounds, you should have good knowledge about the different classes of organic or aromatic compounds, particularly about their physicochemical properties. Not only that, practical experience is also very important. Sometimes it is possible to make some compounds theoretically, but later on it was found that practically it is not possible. Here I shall show some examples for the preparation or synthesis of some aromatic compounds. The knowledge you gathered before about different classes of aromatic compound in my previous classes will help you to understand this. First, I will discuss about the preparation of benzonitrile. One can assume that we can prepare benzonitrile from bromobenzene by one-step reaction using sodium cyanide, but practically this will be not possible because aryl halide does not undergo SN2 reaction, so it's not possible to prepare benzonitrile from bromobenzene by single step. So for the preparation of benzonitrile, we can start from benzene, and we know that if we do nitration, then benzene will be converted to nitrobenzene, and after reduction of the nitrobenzene, it will be converted to aniline. And we know about this step, we already discussed about this step in previous classes. So after conversion to aniline, we can do nitrization using sodium nitrate and hydrochloric acid. In that case, you know that aniline will be converted to benzene diazonium chloride. After that, by replacement reaction, that is Sandmeyer reaction using copper cyanide, if we use, in that case benzene diazonium chloride will be converted to benzonitrile. So by this step we can prepare benzonitrile, but from which step we have to start, it depends on your necessity. We can start from benzene, we can start from nitrobenzene, even we can start from aniline, even we can start from diazonium chloride. It depends on your necessity and the availability and the facilities, everything. So but we can use this synthetic step uh, for the preparation of benzonitrile, and in that case we have to follow many steps to complete this reaction. Now I will discuss about the preparation of ardobenzene from benzene. One can assume that we can get ardobenzene from benzene by one step reaction, that is iodination, but it is not possible to get ardobenzene from benzene by iodination because the structure of benzene and other aromatic compounds are highly stable. Due to the stability of benzene, it doesn't go for addition reaction, rather aromatic compound or benzene go for substitution reaction. That's why by this single step process we cannot get ardobenzene from benzene. In that case we have to follow another synthetic pathway, and these steps are very common to you all because we already discussed about this reaction in our previous chapters. So from benzene we can get nitrobenzene by nitration. After nitration we will get nitrobenzene, and after that we can reduce the nitro group by a reducing agent by reduction reaction. In that case nitrobenzene will be converted to aniline. So after getting aniline we can do nitrization reaction using sodium nitrite and hydrochloric acid. After nitrization, aniline will be converted to benzene diazonium chloride. In this case we have to maintain the temperature below 5 degree. So after getting benzene diazonium chloride, we can do replacement reaction using potassium iodide. And all of you know, in that case, benzene diazonium chloride will be converted to iodobenzene. So using this synthetic pathway, we can prepare iodobenzene from benzene. Now I want to discuss about the preparation of phenol. One can assume that we can get phenol from bromobenzene by nucleophilic substitution reaction using sodium hydroxide in a single step reaction. But it's not possible to get phenol from bromobenzene because all of you know that aryl halides does not undergo for nucleophilic substitution reaction because the bond between carbon and halogen is very strong and less polar. That's why in usual condition aryl halide doesn't undergo for nucleophilic substitution reaction. That's why we cannot get phenol from bromobenzene. So in that case we have to start with benzene for the preparation of phenol. So all of you know that from benzene it's possible to get nitrobenzene by nitration reaction. So after nitration benzene will be converted to nitrobenzene. After that, nitrobenzene can be reduced to aniline by a reduction reaction, and in that case we have to use reducing agent. So we will get after reduction aniline, and using aniline we can go for nitrization reaction to get benzene diazonium chloride using sodium nitrate and hydrochloric acid. And in that case we have to maintain the temperature below 5 degrees centigrade. After getting benzene diazonium chloride, we can go for acidic hydrolysis, and in that case benzene diazonium chloride will be converted to phenol. So using this synthetic step we can prepare phenol from benzene or from nitrobenzene. We can start from aniline or even we can start from benzene diazonium chloride. It depends on your necessity, which is available and which starting material you can use for the preparation of phenol. Now I'll discuss about the preparation of para-bromotoluene. Using toluene we can get para-bromotoluene by bromination reaction, and all of you know that methyl group is orthopara detecting. That's why two type of product will be produced. One is orthobromotoluene and another is para-bromotoluene. In that case we get para-bromotoluene, but my target is to get para-bromotoluene in a pure form. But in that case we will get a mixture of both orthobromotoluene and para-bromotoluene. Problem is that we cannot separate para-bromotoluene from orthobromotoluene because the boiling point of these two isomer is very close. Orthobromotoluene's boiling point is 182 degrees centigrade and the boiling point of para-bromotoluene is 185 degrees centigrade. That's why we cannot separate a mixture of ortho and para-bromotoluene in a reasonable purity using simple distillation or by other separation techniques. We can get some certain percentage of para-bromotoluene, but this para-bromotoluene will be not 100% pure. So in order to get para-bromotoluene in a reasonable yield and purity, we have to follow another synthetic pathway. We can go for nitration using toluene. So after nitration, we'll get orthonitrotoluene and para-nitrotoluene from toluene. Now you can say that how will you separate these two isomer? We can see here the boiling point of these two isomer, one is 222 degrees centigrade and another is 238 degrees centigrade. The difference between the boiling point of these two isomer is far. That's why we can separate these two isomer by distillation or by other separation techniques. So in that case, my target is to get para-bromotoluene. So we have to purify this para-nitrotoluene from the mixture, that is from the ortho isomer. So after separation and purification, we have to use this para-nitrotoluene for reduction reaction using a reducing agent. So after reduction, we know that nitro group will be reduced to amino group. That is para-nitrotoluene will be converted to para-aminotoluene. And using para-aminotoluene, we can go for nitrization reaction using sodium nitrite and hydrochloric acid. In that case, amino group will be converted to diazonium chloride group. So after that, this compound we can go for replacement reaction. Using replacement reaction and using copper bromide, that is, we already discussed the Sandmeyer reaction. Using Sandmeyer reaction, we can convert the diazonium chloride group to bromine. So in that case, we will get para-bromotoluene. So now, using this synthetic procedure or step, we can prepare para-bromotoluene, which was not possible by one-step reaction using toluene after bromination. In synthesis, you may no longer assume that you can separate a pure para isomer from an orthopara mixture. Either look up the physical properties of the compounds or rely on experience gained in the homework as to which mixtures are separable and which ones are not. Now I will discuss about the preparation of meta-bromotoluene from toluene. We cannot get meta-bromotoluene from toluene by one-step bromination reaction because all of you know that methyl group is orthopara directing for electrophilic aromatic substitution reaction. In that case, it's not possible by one-step reaction to get meta-bromotoluene from toluene. So we have to follow another synthetic pathway to get meta-bromotoluene from toluene. We can do nitration using nitric acid and sulfuric acid to get two isomer from toluene, that is, one is orthonitrotoluene and another is para-nitrotoluene. And we already know that there is a difference between the boiling point of these two isomers. So it is possible to separate these two isomers by simple distillation or by other separation technique. So we have to prepare the para isomer, that is para-nitrotoluene. After that, we can go for reduction reaction using reducing reagent. In that case, nitro group will be reduced to amino group and we will get para-aminotoluene from para-nitrotoluene. Now we have to block the primary amino group with a bulky group. Why? Because we already know that in case of aryl amine, the primary amine contain a lone pair of electron which is available for an electrophile. Any electrophile can easily attack the nitrogen because it has a available lone pair electron, and electrophile tie up with this nitrogen in case of any electrophilic substitution reaction. So for this problem, we have to block this amino group with a bulky group. For this blocking, we can go for acetylation reaction using acetic anhydride. So acetic anhydride will produce acetyl electrophile after dissociation, and this electrophile will tie up with this nitrogen. So using this, its lone pair. After that, this amino group will be acetylated and it will be converted to this. After that, we can go for bromination reaction. As amino group is orthopara directing, in that case, bromine as an electrophile will substitute ortho position only, that is this position, because the para position is already occupied by methyl group. So we will get this compound after bromination. After that we have to free this amino group from this acetyl group. For this purpose we can do basic hydrolysis. After basic hydrolysis, this acetyl portion will be removed and amino group will be free. After that we can go for nitrization reaction, the usual reaction, common reaction, and we know that after nitrization amino group will be converted to diazonium chloride group. So we will get this compound after nitrization, and after nitrization we can use this compound to get m-bromotoluene if we react with this compound with phosphorus acid. And we already discussed in our previous chapter that if benzene diazonium chloride react with phosphorus acid, in that case benzene diazonium chloride will be converted to benzene, that is from diazonium chloride nitrogen will be separated as gas, and this will be converted to as m-bromotoluene, which is our target product. That's why using this synthetic step we can get m-bromotoluene from toluene. Here I will discuss about the preparation of m-bromophenol from benzene. So from benzene we can get nitrobenzene by nitration reaction, a common reaction, and all of you know this reaction. So after getting nitrogen we can go for bromination reaction. After bromination we will get meta-bromo nitrobenzene, because nitro group is meta directing for electrophilic aromatic substitution. So after getting meta-bromo nitrobenzene we can go for reduction reaction using a reducing agent. Here we use hydrogen gas in the presence of metal catalyst for reducing agent. So after reduction we know that nitro group will be reduced to amino group. So after reduction we will get meta-bromo-aniline, and after that we can go for a nitrization reaction using sodium nitrite and hydrochloric acid. So using sodium nitrate and hydrochloric acid, that is after nitrization, the amino group will be converted to diazonium chloride group, and after that we can go for acidic hydrolysis. So after acidic hydrolysis meta-bromobenzene diazonium chloride will be converted to meta-bromophenol, and at room temperature, or another sense we can say if the temperature is more than 5 degree centigrade. In that case meta-bromobenzene diazonium chloride will be converted to meta-bromophenol. So following this synthetic step we can prepare meta-bromophenol from benzene. Now I will discuss about the preparation of para-toluic acid from toluene. For this preparation we can follow this synthetic pathway. We can go for nitration. So after nitration toluene will be converted to orthonitrotoluene and para-nitrotoluene, and we already know that we can separate one isomer from another isomer by distillation or by other separation technique, because the difference between the boiling point of these two isomer, and we can purify para isomer, and for this preparation we have to purify this para-nitrotoluene from the mixture. So after purification we can go for reduction reaction using reducing agent. In that case this nitro group will be reduced to amino group, that is we will get para-aminotoluene, and after that we can go for nitrization reaction using sodium nitrite and hydrochloric acid. After nitrization amino group will be converted to diazonium chloride group. So after that we can go for replacement reaction using copper cyanide, and in that case diazonium chloride portion will be replaced by cyanide. So we will get this compound after the replacement reaction. And after that if we do acidic hydrolysis, in that case this cyanide group will be converted to carboxylic acid group, that is the product will be para-toluic acid. So using this step, that is synthetic steps, we can prepare para-toluic acid from toluene. In this slide, I will discuss about the preparation of 1,2,3-tribromobenzene from benzene. For the preparation of this compound, we can follow this synthetic step. First, we can go for nitration. In that case, benzene will be converted to nitrobenzene, and after that we can go for reduction, and after reduction we know that nitro group will be converted to amino group. So we will get aniline from nitrobenzene. So after that we have to block the amino group with a bulky group, because we already know that the lone pair which is present on nitrogen of the amino group, which is available to tie up with an electrophile. If an electrophile attack, in that case rather than the ring, it will tie up with this lone pair of nitrogen. That's why to avoid this problem we have to block the amino group with a bulky group, just to reduce the availability of the lone pair of nitrogen. For this we can go for acetylation reaction using acetic anhydride. In that case, after dissociation of acetic anhydride, acetyl electrophile will be produced, and acetyl electrophile will tie up with the nitrogen using its lone pair. So amino group will be converted to like this, and after that we can go for nitration. In that case, the after nitration, the nitronium electrophile will be produced. It will attack the ring. In that case, it will not attack the nitrogen, because due to the presence of a bulky group, the lone pair is not as much available when the lone pair present in amino group. So in that case, nitronium electrophile will attack the ring and go for substitution reaction. In that case also we get two isomer. One is orthonitro compound and another is paranitro compound. So we have to separate the paranitro isomer, because we need this for the preparation of our target compound, and we can easily separate these two isomer because the difference of the boiling point of these two isomer. So after purification, the para nitro isomer we can use for basic hydrolysis. After basic hydrolysis, the acetyl portion will be removed from this compound, and it will be converted, that is amino group will be free. So we will get para nitro aniline. Directly we cannot get this para nitro aniline from aniline. In that case, if we do nitration, the nitronium electrophile will tie up with this amino group, that is the lone pair which is present on nitrogen. So that's why we have to do extra 3 steps to get para nitro aniline. So after that we can go for bromination. So bromine, if we use a little bit excess amount of bromine, and I told you in my previous classes that halogen are very highly reactive during electrophilic substitution. Due to its high reactivity, it occupies the every possible space for electrophilic substitution reaction. So in that case, we know that amino group is orthopara directing, but the para position is already occupied by nitrogen. So these two ortho position will be occupied by bromonium electrophile, because the amount of bromine is little bit excess, and uh, the halogens are highly reactive. uh, there is a chance of polyhalogenation. So we can get this compound from para nitroaniline after bromination. After that we can go for nitrization reaction, and after nitrization reaction we know that amino group will be converted to diazonium chloride group. ठीक है sir? And after that we can go for replacement reaction, and after replacement reaction diazonium salt portion will be replaced by bromine, and we will get this compound 1 2 3 tribromonitrobenzene. After that 1 2 3 tribromonitrobenzene, we can uh, go for a reduction reaction. After reduction, nitro group will be reduced to amino group, and after getting 1 2 3 tribromoniline, we can go for nitrization, and after nitrization this amino group will be again converted to diazonium chloride. And after that, if we use phosphoric acid, and we know that diazonium chloride will be portion will be replaced from the benzene ring, and this compound will be converted to this compound by following the here the two-step reaction. That is our target product, which is 1 2 3 tribromobenzene. So using this synthetic step we can prepare 1 2 3 tribromobenzene from benzene. Here I want to discuss about the preparation of 1,3,5 tribromobenzene from benzene. So using this synthetic step we can prepare our target product from benzene. For this we have to do nitration first. So after nitration we know that benzene will be converted to nitrobenzene, and after that we will go for reduction reaction using reducing agent. In that case nitro group will be reduced to amino group, that is we will get aniline after reduction. In this stage or in this step we can go for bromination reaction. We have to use aqueous bromine a little bit large excess than the ratio of aniline. We already discussed in aromatic halo compound or in previous slide that bromines are or halogens are highly reactive. If we use pure halogen or bromine, in that case this halogen will occupy the every possible position during electrophilic aromatic substitution. That is, there is a chance of polyhalogenation if we use halogen in pure form and the amount is a little bit larger than another reacting substance. So after bromination we will get 1,3,5 tribromoaniline, because we know that amino group is orthopara directing. So bromine as an electrophile bromonium ion will substitute the three position, two ortho position and one para position. So this product will be produced after bromination. In that step, in this step we can go for nitrization reaction using sodium nitrite and hydrochloric acid, and we know that after nitrization amino group will be converted to diazonium chloride group. So we will get 1,3,5 tribromobenzene diazonium chloride. And we also know that if we use phosphoric acid, in that case diazonium chloride group will be removed from the benzene ring. So after using phosphorus acid, that is one kind of replacement reaction. In that case, 1,3,5 tribromobenzene diazonium chloride will be converted to 1,3,5 tribromobenzene, which is our target product. So using these synthetic steps, we can prepare 1,3,5 tribromobenzene from benzene. In this lecture video, I tried to discuss about the preparation of some simple aromatic compounds. Hope it will be helpful for you all. If you like my lecture video, then don't forget to click the like button. You can also share this video to your friends and can also put your comments. Lastly, don't forget to subscribe my channel. Your subscription will encourage me to make more lecture videos for you all. Thank you.